If you like laws, well here's one for you. If you want to break it, then you must be a fool. Coulomb's the man, the genius, my idol. He's so great, they gave this law his title. Two particles with the same charge have the same characteristics, but if they're close to each other, then you must know it's a mischief. Negative charges will stay negative. Who said two negatives will make a positive? If they look the same, they hate each other. Have you heard of two girls wearing the same attire, but instead of going close to start a fight, they run away to get out of sight? Here's a summary if you're lost. Remember this at any cost. Charge 1, charge 2, get together to make a force that is like none other. Distance squared divides those friends, but Coulomb's constant will make amends.
We're here to talk about Coulomb's law, known as the electric force equation, a non-contact force between charged objects acting over the same distance of separation. F equals Q1 times Q2 over squared D, all times Coulomb's constant Ke. The Coulomb force is quite similar to the force of gravity, with a couple of differences. For example, electric forces are stronger than gravity in all instances, and while electric forces can be attractive or repulsive, gravity is always attractive. Yeah, it's not that impressive. You need at least 2 charges, but it's no problem to have 3, and using Coulomb's law you can calculate where the third charge might be. When you have multiple charges, you need to use vectors, because each charge exerts a force beyond its own sector.
Here's a summary if you're lost. Remember this at any cost. Charge 1, charge 2, get together to make a force that is like none other. Distance squared divides those friends, but Coulomb's constant will make amends.
Now comes the concept of distance. You should know it's all part of a system. The farther that they're apart, slimmer the chance to fall in love. You know how relationships are, the long distance ones leave a scar. And the force between the two will be close to none, because they don't know what's going on. We study particles small and close, because it has a force that always goes. 8.99 times 10 to the 9 is a number to keep in mind.
Here's a summary if you're lost. Remember this at any cost. Charge 1, charge 2, get together to make a force that is like none other. Distance squared divides those friends, but Coulomb's constant will make amends.
The year was 1785 when Charles Coulomb blessed us with this beautiful law. Now we've all embraced it, grasped it with our great big claws. Out of all the laws, this one is surely the best, because it puts the charges to the ultimate test. Coulomb, sometimes I dream about us gazing into stars, thinking about charges and calculating how far they'd move apart. And I know, Coulomb, you and I are not charges, but if you were a positive, I'd sure as hell make myself a negative.